today's video, we're treating on the topic on dimensional analysis. When we talk about dimensional analysis, what comes to mind? Dimensional analysis is the method used in science and engineering, which is used to check whether equations are correct or not. That is, to check whether equations make sense and to convert between different units. We have the importance of dimensional analysis. So at the end of this video, you know what dimensional analysis is, the importance, and solve more examples on the dimensional analysis. So back to the importance. With the importance, it helps us to check whether equations are right or not. It helps us to convert between different units properly and to help us to understand the relationship between different physical quantities. So up next, we're solving more examples under dimensional analysis to check whether equations are right or wrong. So next up, before we tackle this question, to know whether this question distance formula is correct or not, we have quantities we used in solving for dimensional analysis, and these are the units here. So with the length, we know that length is L, mass is M, time is T. These are the quantities used in dimensional analysis, and we'll be using them more frequently. So here, distance has the quantity L for the length. Speed has the quantity, the formula for speed. Speed equals distance over time. Are you getting it? So then it has a dimension of length t minus 1 from indices. Negative 1 on top means that it's 1 over that quantity. So then it's L over t. And time here, we have time to be equal to t. So then know that distance here. So to check whether this equation is correct, we equate them. But first, any number raised to the power 0 is what? 1. So then you can write that m raised to the power 0, L raised to the power 1, and t raised to the power 0. That's all. This is the same as the distance. And the speed is L times the t here, time. So to check, we must know that ice cream here must be equal to the ice cream here. But ice cream here can't be equal to the pizza here. Are you getting it? Sure. So we are checking whether it's correct or not. So then we know that we have m0 here. There's no m here. So let's form one equation. So then L times, so we have this, because it's multiplying from indices, we add them. So then plus 1 minus 1 plus 1 is 0. So we have this to be L equals L. So therefore, the equation is dimensionally what? Correct. Try pausing the video and solve for this, whether this force formula is dimensionally correct or not. It says that force equals mass plus acceleration. Okay, so we know that with the formula for force, force is equal to the mass times the acceleration. So we have force has the dimension of mass times acceleration. Acceleration is this, and mass times acceleration, and we have mass to be equal to m from the quantities, and acceleration, let's say small a, equals the velocity over time. That's this. Velocity is L t minus 1. So then we're checking whether this is dimensionally right or not. So we have this to be m L t minus 2 equals the m plus the L t minus 2. Are we done? Yes. And is it right? No. Why? Because this is addition. When it multiplies, that's when they can be dimensionally right. But since it's addition here, the formula here is not m plus L t minus 2. But here is m plus, so then it's not the same as this. Therefore, but first, what is the dimensional analysis for velocity? Someone may ask, why do you get the LT minus 2 for the acceleration. Dimensional analysis for velocity is what we solved first. So then velocity equals the displacement, the change in displacement per time. And here displacement is L, time is T. Therefore velocity is T, LT minus 1 equals this. So this we can know that is dimensionally right. And acceleration here is this velocity over time. So velocity over time equals acceleration, where acceleration equals LT minus 1. That's for the velocity over time. Therefore, LT minus 2 equals the acceleration. So let's go to the next question. We have to check for this question. Frequency. Frequency is always the inverse of time. The inverse of period is frequency. So then we have to check whether this equation is right or not. So we know that for frequency and we have time. What's the dimensional analysis for time? T. So from our indices, we know that this equals that. So this equation is what? Dimensionally correct. Pause the video and check whether this is dimensionally right or not. So by so doing, know that the dimensional analysis for KE is of, that is the kinetic energy, equals the mL squared T minus 2, and mass here is m, V is what? L T minus 1 from the previous explanation I gave. So we have this to be mL squared T minus 2 equals half m, that's this multiplying, we bring a square bracket, L squared. So then we come here again, mL squared m equals. So now we want to remove the bracket. So then from indices, whenever there is bracket, it multiplies everything here. So then L squared T, negative 1 times 2 is negative 2. So is this dimensionally correct or not? You said it's wrong. Why? Because of the half. No. With dimensional analysis, the number in front, that's the integer, doesn't matter. Only the formula matters. That's the units, the quantities. They matter once they are equal. No matter the number here, whether it's 0.84 or any number in front of the quantity, doesn't matter for determining whether the equation is right or not. So with this, the formula is dimensionally correct. So hope you like this video. Please like and subscribe to EM Links.